let's go ahead and get started. Alex, thank you so much for coming. I appreciate you taking the time to chat with us. This is really exciting.
Yeah, thanks for the invite. Really looking forward to chatting with you.
So for anybody that doesn't know what Alex does, you can see on
Most
the
people.
you can see on that slide that I was just sharing, he's the lead data scientist at TrueLayer. And today we really wanted to talk about machine learning in open banking. I also wanted to talk about, you wrote a great blog article on the hiring process of a machine learning engineer. And then I wanted to talk about the machine learning infrastructure or the MLOps pipeline that you've created at TrueLayer. But before we get into any of that stuff, let's go ahead and start with, how'd you get into tech?
Okay, so I'm probably the only person in the audience who will know this, but the Allstat mailing list. What is the Allstat mailing list? Okay, so it's interesting. So back in 2009 or something, 2010, I was kind of fresh out of my degree in mathematics statistics, and I was trying to figure out, to be honest, what to do, which direction to go down. And there's this like mailing list. I was in Greece at the time, and there's this Royal Statistical Society mailing list that was kind of posting, job adverts, news about like statistics back then. And I saw, like, I was looking for, where am I going to go? Like, I didn't really have a clear direction. And these new like data science, big data kind of messages started coming through, and really, like, I had no idea at the time, and it really became interesting to me. And I started researching online, and it was about the time where this really like big explosion was happening, like in the States, and moving over to Europe and stuff. And yeah, I think that really kind of just being part of like something that's so like evolving and dynamic back then, as contrasted to like the traditional statistics, become an actuary, or no offense, but like or become an epidemiologist. Now this is really cool. Okay, but it's a bit more it was a bit more stagnant, and like the tech side became really interesting, and like being part of something big, and like so then I decided, like, okay, I probably don't have the right skills. I need to upskill a little bit. And I had the opportunity to do a master's in the UK, where I focused a lot on the computational side of statistics, which led me to more machine learning, right? And then, yeah, that's more or less how then after that, it's kind of unfolded naturally, to be honest.
Perfect. And what has your trajectory been so far? You went to the UK, you started doing this, you started completing your studies, and then you got a job in machine learning right away, or how did that look?
Oh, no. So I started out doing, like, in Greece, I was doing like statistical research on biomedical projects. So the epidemiologist thing I said was actually an option for me at the time. But then, yeah, I went and did like my master's degree here in Leeds. And this kind of internship opportunity came up with this kind of oil and gas services kind of company that essentially scanned the subsurface for kind of oil reservoirs. And there was a really nice opportunity to introduce machine learning techniques into that process. So I did an internship there, and it was a really good experience, like in terms of technical kind of things I learned, and I decided to give it a shot. To be honest, that was not for me in the end, neither the industry or that much, or like the mindset. I would say a little bit more like closed as an industry, like very much introverted rather than extroverted. So yeah, so a big opportunity came along after a lot of like effort. It was one of the hardest things that I had to do. Like at that time, it wasn't really established. Data science wasn't really established, like in 2014 here in the UK. So companies didn't know how to hire for data scientists mostly, right? People will remember that like you had these bucket lists of like skills, like you need to be like master of algorithms, master of statistics, master of the universe. And it was hard to get a job. It was the hardest thing I've ever done. But in the end, this opportunity came along, and it was with IBM, which was very kind of educational and a very good kind of transition into like doing data science work, formally data science work. It was a bit more like on the, yeah, I can go a bit deeper into that, but after IBM, I moved on to a startup called Black Swan Data, where I worked on like the core data science team, building out algorithms for predicting kind of the next big thing in like fast moving consumer goods using social data. That was interesting. And I moved to TrueLayer about 2 years ago. So to be honest, it's a bit of a convoluted path, but it's interesting.
Yeah, completely. And so now jumping and looking at TrueLayer and what they do, can you just give everyone a bit of background on what they are doing and how they're using machine learning?
Okay, I'll start with the most like an interesting introduction. So PSD2. This is a European regulation that came into force a few years ago. And I'm going to give the most like the worst intro to it ever. But essentially what this European regulation, which is called open banking in the UK, was all about kind of forcing financial institutions to open up their systems to enable kind of innovation in financial kind of services and financial technology. What does that mean? So the regulation forced banks to create APIs where applications can connect to and fetch data of users who consent for their data to be shared. So one of the best examples I can think of is like Yolt, who are a kind of, you know, personal finance manager. You know, with Yolt, you connect to your bank account and it fetches back your transactions, and it does a bunch of stuff on top of that, right? So to get that connectivity before PSD2, it was all about creating like screen scraping connections, which is not great for many reasons. But PSD2 forced the banks to create dedicated APIs for this. So it opened up a really kind of big.
Before PSD2, was it the banks were keeping all this data for themselves and they weren't allowing anyone to get into it?
They would, but it was a little bit, so applications would have to build, to essentially reverse engineer the login flows of when you log into open banking, for example. And that was not really scalable and not really like, you know, the bank changes the interface, your whole connection is broken, right? So and that's still the case in the US, for example. But in Europe, we have PSD2. So the banks have APIs for this job. You don't have to reverse engineer like the online banking system to get users' data to incorporate into your application. So yeah, data side is one, and payments is another very interesting application whereby you can initiate payments directly from one bank account to go to another, circumventing essentially MasterCard, Visa, and other kind of payment processing technologies.
Okay, cool. And so then TrueLayer is doing what in that space?
Yeah, so TrueLayer is on kind of on both aspects of PSD2. So we have products in the data space and products in the payment space. I personally can speak more about the data space kind of work stream. So essentially, we're an API company. We solve like on the data side, the problem we kind of solve is, you know, let's say you're a company like a personal finance manager, right? And you have a bunch of users, or they have different bank accounts. They bank with different providers. You have the choice of either building out and maintaining all these connections yourself, or you go to a central place who manages all that complexity for you. So TrueLayer are kind of a bridge between the application and the financial institution in that way.
Okay, nice. And now what exactly are you doing in the machine learning space with all of that information?
Yeah. So onto the cool stuff. So so fetching the raw information is one thing, right? So you can fetch a user's, applications can fetch transactions of users upon the user's consent, do stuff with them, whatever. But that's, you can do, like, there's so much more one can do. So you can start building interesting stuff on top of the raw transactions. So you could be adding more contextual information. So you can, for example, identify what is the nature of this transaction. Is it kind of regular salary? Is it, if it's spending, is it shopping? Is it like utilities? Sorry, is it like paying for petrol? You can do all these interesting things about the nature of the transactions themselves. So that's one layer. Then you can go one layer further. That's not a pun with the TrueLayer. That was just random. Sorry. And you can build like insights products that are built on top of the raw transactions entirely. So you can say, oh, these are the aggregate behaviors for this specific user. So you can say, over time, over category. And this really makes it easier for applications who use us to use those insights directly rather than having to build them out themselves. And this is an area where machine learning is currently quite prominent at TrueLayer.
And how did you decide to use machine learning instead of just regular rules-based algorithms?
Yeah, so another interesting area. So when you start out to conceptually, when you start out to solve a problem, you don't necessarily understand the complexity when we're talking about like data-enabled products. So you start out with the simplest approach possible, right? And you see where that gets you. You have to then measure, and you have to make a judgment call whether it's worth going more complex or keeping it simple. So we started out with rules. We started out saying, okay, if this is a debit card transaction and it contains the string whatever, then it is, contains the string Uber, then it's kind of a taxi, a taxi kind of type of transaction. And I guess another thing you can do is you can identify the merchant or the entity name from the transaction using a similar methodology. Okay, that works like that works for a certain amount of time, assuming transaction descriptions which we are using are kind of stable. And of course they differ by provider. And yeah, assuming that no other kind of logic falls apart, then you can maybe identify up to 60% of the overall transactions flowing through your system. But that's not enough, right? You need to do more. So you have the option of building a bunch of more rules that are prone to change and break, or you can do something different. And as your audience will be very familiar with, of much simpler ways to use supervised learning through kind of human annotation. And we made that judgment call. We always, to be honest, it was always in the back of our minds, but kind of commercial pressure to improve our product and personal kind of team drive to start making our methods more sophisticated led to us making the jump. I guess the jump itself was more gradual. So we started out with a hybrid kind of rules-based machine learning approach. And I guess we are still using that approach. And we're considering whether to keep it or whether to move to a fully machine learning based kind of system.
And the first question that pops out in my mind is, how long was it and how much suffering was it when you were going through this rules-based, and did you instinctively think, let's just throw machine learning at it? Or was it something that it really had to go through the whole organization and they had to recognize that this was the fix for the problem?
I think like we were pretty autonomous. Like in the end, from a team point of view, we were expected to get the expectation from the business is to get this thing working as best as possible. So the buy-in wasn't really an issue. In terms of like the team itself, so I guess yeah, it was just becoming a bit intractable to keep on building rules and yeah, just for example, reacting to cases where our classification was wrong. So you can imagine like users of this classification service were saying, oh, this is a wrong category. What can you do about it? So you can either go write a new rule, you know, with whatever that chaos that might entail, or you can actually leverage that feedback from the client in a loop kind of way in order to incrementally improve your system. And that's where machine learning like really shown as like the golden kind of solution there.
Yeah, it starts to shine. And now pivoting to infrastructure, you guys decided, hey, well, we need to go into machine learning. We want to use this. How does your infrastructure look now? How did it evolve over time? Where did you start? Where did you come to? And why?
Yeah. So TrueLayer runs Kubernetes on AWS. This is our kind of core infrastructure. And I guess the service the team kind of started working out with, given that it's our core programming language at the moment, was in C#. So kind of the rules-based kind of classification engine was written in as a microservice in C#. So I got to learn a bit of C# in the process, which I hadn't have any, you know, personally any exposure to before. And yeah, so, but when we're talking about introducing like machine learning, I guess your audience would agree that C# is probably not the first option one would go with. And I guess it made a lot of sense to create our first, I'm not sure if it was the first, but one of the first kind of Python microservices in production for this use case. So yeah, so microservices, they communicate through REST API. And well, there's a mix, but this microservice in specific was written in Flask. So yeah, it's a Python Flask microservice, basically.
I think we might have lost Demetrios. Well, while we're waiting for Demetrios to jump back on board here, just really quickly, if you have questions, feel free. You can unmute yourself. You can also ask a question in the chat, or just say, I have a question, and we'll call on you that way.
We actually have a question from Chris Harden. Chris, do you want to say your question out loud if you don't mind?
Oh, no problem. Is my mic working?
Yeah,
I can hear you.
A little quiet, but go ahead.
Perfect. Okay. When working in the financial services space, decisions that are made on suitability of customers and credit scores need to be auditable down to the decision level. When using machine learning, do you avoid using black box decision making, or is there another method you use to overcome this?
Yeah, that's a great question. I guess our clients, users, in order to identify kind of the creditworthiness of their users. So many of our clients are in the credit space, in the lending space. So as you can imagine, like for example, if we make an estimate on a user's income, which is then in turn used for making a credit decision on that user, then it is very important to be able to reproduce and replay the exact kind of machine learning model kind of workflow that produced this estimate. So indeed, the financial services industry is very tightly regulated. And added to that, there needs to be a layer, as you mentioned, of interpretability. So clearly there is a big bias for us to use the simplest, the most interpretable kind of algorithm available to us. So we are averse to going more complex than required due to the regulatory kind of environment. Don't know if that answers your question.
Absolutely, yes, thank you.
Cool. So sorry, I just dropped off for a minute, and looks like you had some good questions going on. I see another question in the chat. We can go ahead and answer that real quick before we move forward. Thomas was asking, apart from Python Flask, do you build applications yourself with normal tools, or do you use any other library which is a core for the application?
So I can only answer in this sense on the Python side. I wouldn't say I'm the specialist kind of backend engineer at TrueLayer. In terms of our Python microservices, I guess they're APIs, and we tend to use a mix of different kind of libraries for that. Depending on whether we're using asynchronous or asynchronous APIs, we tend to use either Flask. We had experimented with Sonic in one occasion, and last year Fast API got out, was released, and I've been extremely impressed with Fast API as a whole. So yeah, I don't know again if that answers your question.
I would imagine it does. So let's continue. I'm not sure what I missed as far as the MLOps pipeline that you put forth and the evolution of that, but I wanted to talk about just the regulation and the reproducibility and how important you feel that is when it comes to the whole pipeline and what you're doing with the data science.
Yeah, I guess we covered this a little bit before. So reproducibility is a very strong requirement in the space we operate. So yeah, so being able to replay our decisions, decisions of an algorithm made 6 months ago, need to be there. So can imagine in production you get a different, a host of models can be deployed over a period of time, and having the ability to pinpoint which exact code kind of produced which exact result, which data set was used, which parameters we used. All these are requirements for us to be able to replay that decision. And that's where I guess .science was very useful for us, as it provided that missing element to kind of a traditional Git kind of version control system for being able to track that kind of provenance end to end. Yeah.
Perfect. So I see in the chat, there's also another question asked by Adam Butler, and I also see yours, Nick, so we'll get to that in a second. Can you get explicit details or infer anything? And if you already answer this, let me know, but can you get explicit details or infer anything about the items that somebody purchased during open banking? For instance, could you differentiate between somebody's purchase at Sainsbury's versus them getting petrol at the Sainsbury's petrol station?
So in this specific example, I guess it may be the case. So the data we have to work with are details about the transaction itself, and these are the description. This is the amount. This is the timestamp, and some metadata regarding the nature of the transaction. So how was the payment? So what was the kind of transaction method? And these are the basic information we have to work with. So in this specific example, I seem to remember that Sainsbury's and Sainsbury's petrol station may have a different description. So I think this is something we can differentiate between. But I think the question itself is more about, for example, you have an Amazon transaction, right? Could be anything. So at this stage, we can't differentiate. I've heard of this may be a little bit off topic, but I've heard that Monzo is working with a company called Flux, who do receipt. So they're incorporating some receipt kind of management system, which can tell you more granularly what each transaction is, the receipt attached to each transaction. And that, in my mind, sounds very interesting. But it's a capability we don't currently have. We cannot know, right? So if you see an Amazon transaction, £5, who knows what it is, right? That being said, I think there are ways one can understand using with a large amount of annotated data. There are things that can be done in this space, but we're not there yet.
Amazon transaction, £5. It's probably a face mask or,
well,
or toilet paper.
£50, yeah.
Yeah. So getting back into it, you mentioned to me before, I don't know if you said it here, but you're using Prometheus and Grafana for monitoring. And can you give us some use cases on how you're monitoring and how you're setting up the dashboards when you have these and what you're focusing on?
Yeah, we're an API company. We run on microservices. So as you can imagine, Prometheus is kind of the best way to monitor APIs in production. We use Prometheus across our stack. And kind of the machine learning services are no different. So for our Flask service, there was a nice library we used called Prometheus Flask Exporter, I seem to remember, and which is a nice kind of library that helps you instrument kind of the Prometheus metrics for specific Python applications. So the way we use it is, it's a microservice. We report things like latency, like error rate, as is pretty standard. But because we're talking about a machine learning service, we also surface things like the distribution of inputs over time, distribution of predictions, of category frequencies over time. And we use Grafana to basically show all these things nicely in a dashboard that we look at every day and smile or not smile. We usually smile, but yeah.
Cool. So as you look at the whole MLOps pipeline that you have set up, are there any places where you feel there's a black hole or anything that you would like to fix, you don't feel that you're doing well, or now that time has passed, you feel like this could be done better?
Well, that's an interesting question. I think we're quite happy at the moment. I guess to be honest, as a data scientist, what I really want to know is like, is my model making the right call, like on aggregate or not? And the way I currently understand this is through proxies, the proxies I mentioned before. I guess what would be really amazing is, and this is me thinking out loud, right? If we had an automated way to kind of capture the accuracy of this service, like in the wild, through some programmatically like executed human annotation service on anonymous data, and integrated into the Grafana dashboard, that could be kind of a way to have everything in place, right? Because rather than proxies of the actual performance, you could have the actual human reviewed performance, maybe on a different time scale, but still it would be in a place where you could actually see it. But that's me talking out loud here.
There you go. Luke is scribbling notes frantically. I can see him there. So
this is a good product idea.
so there's some questions from Nick. I feel bad. I haven't been ignoring you, Nick. I want to get to some of your questions. You've got some great ones. Let's start from this bottom one. In Prometheus and Grafana, are you limited by its matching to data being by regular expressions as opposed to numerical by data types?
Yeah, so I guess I see where this question is coming from. So in terms of like the rule-based, it's kind of hard to apply the same logic for the rules-based part of the system. I guess in terms of like the rules, what we try and do is like we try and like look at the classification, like the coverage. So how many of the actual cases were successfully labeled by the rules-based one, and we surface this. But yeah, that's a good shout actually. We use the classic kind of API metrics in Prometheus for the rules-based service, but for it doesn't exactly kind of fall into the same kind of monitoring paradigm as the machine learning one at the moment.
Perfect. So let's ask another one that we had in the chat here, and then we'll move on. Do you find the performance of Python Flask is okay? Are there limitations with that setup in production?
Yeah, so it's okay. Basically, obviously it's asynchronous. Sorry, it is synchronous. So I guess there may be cases when we start scaling a lot, when we will probably have to move to an asynchronous kind. And if our machine learning models become a little bit more sophisticated, or not rather than sophisticated, I'd say resource intensive, potentially adding a little bit of latency than what we have today. That could happen by making our kind of API a bit more flexible in terms of, I want to throw the kitchen sink at this problem, or I want a light version of the classification that is kind of product choice. Yeah, I mean, we might move to an asynchronous web server, but at the moment it's working fine for us with the scale we currently have.
Cool. So moving on to the blog post that you wrote about hiring an ML engineer. Just as a bit of background information for everyone, can you explain what was going on? You were tasked with hiring someone as an ML engineer, is that right?
Yeah, so lots of questions here. So why an ML engineer, right? What is the exact skill set we're after? And we're essentially looking for someone who is very able to take on like generic engineering tasks, but who also have a strong appreciation of like the machine learning workflow end to end. Okay, you're asking for everything here a little bit, which is always the pitfall in hiring. So I think in the end, we're looking for someone with very kind of generalist kind of programming skills that are modern and applicable to today's world. I can go a bit deeper into that, but with a differentiation that not everyone has these end-to-end like machine learning, an understanding of what machine learning prototyping is all about, right? So we're looking for essentially an engineer who gets machine learning. That's like in the nutshell what we were looking for.
Cool. So I just saw we got another question from Sebastian, and it's more on this pipeline. And so I want to complete that before we jump into this hiring piece. And Sebastian's asking, how much of this machine learning pipeline were you able to automate?
It's automated in the sense that, Kubernetes, from the kind of engineering point of view, it's automated through Kubernetes. I guess from our side, when we want to, it would be nice to be able to perhaps automate retraining of models once accuracy falls below a specific threshold. That's not something we do today. I think that would be a really cool use case, again, when we start getting scale and when we are in a place where we can establish data pipelines that update training data kind of more automatically. So yeah, so I guess if the question is around, what happens when you want to deploy a new model? Yeah, sure, it's manual, but then I guess it's taken care of continuous like deployment, continuous integration, and the training is at the moment automatic, and the deployment is automatic through Kubernetes and GitOps, through the GitOps kind of continuous deployment workflow that we use. I don't know if that answers the question.
Just a thought here, Alex, it might be nice to share a little bit with the group here about how the GitHub CircleCI.science pipeline works and kind of how you plug that together. Because I thought that was a really cool piece of engineering that you did. And I think that kind of answers one aspect of the automation question, kind of push to Git.
Yeah, a big shout out to my colleague Luca Palmieri, who took the lead in creating that integration. So I guess at TrueLayer we're at a size where we want to stick with our existing kind of deployment patterns across all our services. So we were trying to find a way where we can be able to deploy machine learning services in pretty much the same way as we deploy any service. So currently we use CircleCI at TrueLayer, which is our kind of build and deploy tool. And I guess we use .science as discussed before, to give us that reproducibility and that kind of collaboration dimension that we were looking for. And essentially, it was not that tricky at all in the end. It was we used the .science kind of Python library to annotate our existing machine learning Python workflow. So that happened at the application level. And when we deployed, we essentially triggered a bunch of CircleCI jobs that build the service. Then we had a train and save flow within CircleCI. So that's the most interesting bit. So the train and save flow essentially spawned off a job in our dedicated kind of .science cluster on the .science runner that fetched data from an S3 bucket, ran the machine learning workflow, and essentially we could then review the accuracy and performance of that training process. And then there was a bit of a manual step where we had to go back to CircleCI and manually approve the next step, which is the deployment phase. And yeah, after that, it was all in Kubernetes territory in terms of deployment. So it was pretty simple, I think, in the end. The moving parts are, the S3 bucket, kind of the .science cluster, and CircleCI in the middle, orchestrating the communication. And yeah, I guess we've been chatting with .science about the chance to automate that flow even further. So I guess now there's the option to actually get a webhook back from the .science kind of job, telling you whether the job is finished and whether the accuracy, and a custom rule you can say where the accuracy is above a certain kind of limit. Yeah, so that's at a high level what we're doing.
Nice, cool. So pivoting back now into this hiring and what was going on there, I thought it was really interesting in your blog how you talked about the third wave of data scientists. Can you go into that a bit more?
Yeah. I think I'm in a position where I can answer this well, because I feel I've been part of every kind of wave, if you want to call it that. So I think this all starts to make sense after around 2011 or something. Especially okay, we always had the pioneers that Google, Facebook, Twitter, whoever, who were early adopters and early they adopted machine learning first and were on the forefront. But I guess the rest of the world was a little bit using various proprietary kind of tools, doing very similar work, but it was kind of all locked in and pretty not really, it was an opaque kind of world. And I guess that's the first wave in a nutshell. And then this big data revolution happened, and particularly where I think the second wave kicked in was Jupyter notebooks. So that was just a profound moment in the data science community, and it just opened up Python and data science to the whole world. It was this this brilliant moment, and everyone suddenly became, I would say, including myself, everyone suddenly became like a data scientist. And there was massive like excitement, massive hype of the like possibilities that machine learning and data science can bring to enterprise, to business. And I think we were rolling in that kind of wave for maybe 3 or 4 years. But in the end, I think businesses didn't really know how to extract business value, a lot of business value out of kind of data science, Jupyter Notebook data science, as it was back then. So you ended up with situations where it was just like shelfware, PowerPoints, things that were created in a vacuum and were never put in production. And I think there was a lot of that in business during the second wave. So it was kind of a hype time, but a time where business value wasn't optimally extracted. And I think the lesson learned there was like that data scientists cannot just be people who, write Jupyter notebooks in a vacuum. They have to be involved in the end-to-end process of actually prototyping something and then ensuring that it gets pushed into production. And I think there's a recognition amongst like businesses nowadays that this is kind of, a given. This is kind of a requirement nowadays for the data scientist or, machine learning engineer, whatever, kind of jobs. So yeah, working in a vacuum in Jupyter notebooks is not an option, I think, anymore. And the whole industry is coming to that realization. And I think that's the third wave of like the full stack kind of data scientist.
Great. And now talk to us a bit about this idea of the different mentalities between machine learning engineers and data scientists.
So I think data scientists should be used to fail a lot, right? So it's so I think like data scientists are specialists in failure, and I mean that in a great way. I'm joking. So I think data science, I do see a distinction. So I think data scientists are basically specialists in experimentation, which means that you're constantly testing hypotheses, constantly, not validating your hypotheses. And then you have this mindset, you have to keep pushing on. And in the end, you might not even like, get the answer that you want, right? So in a way, you need to be really like tolerant to failure. But on the other hand, I think that, and this is just my point of view, right? I think machine learning engineer is kind of intolerant, like should not tolerate failure. I think machine learning engineers are more about getting something like and deploying it and putting it out to the world, right? So this is a process that shouldn't go wrong. This should be a process that you should strive for perfection, and it's something that you can do. Machine learning engineers should be able to like create a model that gets you 80% of the way, but should be able to put it into production like and it should work like that. That is not a failure that the machine learning engineer can tolerate. So in that sense, I guess the highest level distinction is like focus on experimentation on the data scientist and focus on end-to-end like functionality on the machine learning engineer side. And I think that, and from like data scientists and machine learning engineers I've come across in my career, I think it's difficult to be both. Again, people will argue they're pretty much the same, and I do kind of agree, but I think that mentality of like experimentation, of like very focused experimentation, does not translate very well to machine learning engineers, and people may have a different opinion on that.
Yeah, that's a great summary of it. So Thomas has a question here in the chat. He's asking, do you expect these distinctions will merge together in the near future, and there will be another kind of position? Or what do you predict and how it will evolve in, say, 10 years? And this kind of is one of the questions I wanted to ask you too, is do you feel like there's a difference between a machine learning engineer and an MLOps person? Is there any, if there is anything? Yeah.
So yeah, I think the names like nowadays, yeah, I don't know how much sense like names make anymore, to be honest. You know, you go into a company, you have a specific, you know, or maybe non-specific, but you kind of work on stuff. And then you kind of decide whether, you know, whether you're a machine learning engineer or a data scientist, or I don't know. So to be honest, I think names will definitely evolve. But I also think like, and you guys have been saying this too, that I think, you know, the role is evolving and is becoming a little bit more well-defined. So like the machine learning engineer thing, yeah, it's real. It's all about like end-to-end stuff. So yeah, now going to your machine learning engineer versus MLOps, I would hold my hands up there and say, I don't know. But yeah. Prediction-wise, I think the data scientist thing is not going to be around forever. I think like it's becoming a little bit, I think there's so much baggage associated with this kind of role name nowadays. There's a lot of damage as well, like to what it means to be a data scientist. Such an umbrella term, and I think, yeah, definitely it will be broken down into things that make more sense.
Where do you see it evolving into? Just more specific terms?
Yeah, I think we'll probably go back to more basic stuff like so I think data scientist might become like what it once was. So go a little bit. It will make sense for companies to do R&D and do a lot of like experimentation because it's science role, right? I think things will move more towards the engineering naming side. So I think like the machine learning or the I don't know, like data engineering, like kind of perturbation will become more prominent compared to data scientist. Yeah, I don't know. That's not a great answer, but kind of, yeah.
No, it's perfect. It's perfect. And so I'm wondering about this because you spoke about with like a ML engineer needs to be able to work with this end to end, and end to end these days is a very big buzzword. And in your blog post, you spoke about random buzzwords that companies will put out when they're hiring for an ML engineer. Can you go into that a bit more?
You mean in terms of the buzzwords or like?
Yeah, and how you feel about what that entails, because it's like companies will just throw a sheet of buzzwords that they want, but they don't really know what they're actually looking for.
Yeah, it's like the trophy data scientist, like a phenomenon that we encountered. Like you know, some guy in the some person in the business like decides, oh, I want a data scientist. Like I want to look cool to my boss. How do I actually need data scientist? Who knows? What does a data scientist need? Oh, they need MongoDB. Oh, they need Spark. They need I don't know, like IBM Watson. Oh, they need, I don't know. And it ends up like being in these like job specs, and you can really easily understand like whether the people, you know, whether the business is serious about who they want to hire just by looking at the job spec nowadays. And I do encourage people to really take job specs like with a critical eye and like ask themselves, does this really make sense? So if I do join this company, do they know what they expect from me? And I think this is a real tell. But yeah, buzzwords were really entertaining like a few years ago, especially when it was all like the Wild West. I wish I like kept like job like specs and I could make maybe, you know, a little website there, a little collection. But yeah, avoid buzzwords, like avoid shopping lists. Like if you're putting out specs, like just keep it like, you know, keep it concise and keep it like logical. There are no unicorns. Okay, there are some unicorns, but you're not, yeah, you know what I mean?
Yeah, completely. And now it looks like we got about 5 minutes left. I want to make sure that everybody feels like their questions got answered. So if anybody has any questions for Alex, please throw them in the chat or just unmute yourself. Feel free to say hi and talk. And if not, I'll wait, you know, a good 5 seconds. And if not, I'll ask my final question.
got one that may have already been answered.
There we go. Go for it, Charles.
Sweet. So MLOps, to me, I always hear it and think of DevOps. And obviously we've spent ages in the engineering community desperately trying to make it so that we have this really rigorous way of ensuring that the artifact that I've made on my machine is the same artifact that appears in dev, and then it appears in staging, and then it appears in prod. In other words, I get no surprises. There's nothing different about what's going in prod. And that goes all the way through to like configuration as well. You want to make a configuration change, you push it through the pipeline. Like in the ML world, it feels like that's a slightly different paradigm. Almost feels like that's the paradigm you don't want to follow, because you want to be changing that ML artifact in production. Do you see like a totally different approach to like operations, deployment operations, changes in production to what we've developed in the world of DevOps in engineering?
So I think the answer, I think, is that these things are merging. So the engineering community really faced these problems like 20 years ago, or maybe before that, I'm not entirely sure. And I think we're just the past like few years, we've been trying to solve them really well in machine learning. I think we will arrive at a similar paradigm. And I think version control and provenance is obviously like essential to that. But yeah, I guess this is a very high level answer, but I think we will be maturing to something that looks similar to what we have in engineering. And I guess Luke is someone who's a bit of a thought leader as well on that subject. So feel free to jump in, Luke.
Well, I was just going to say I have opinions on this, which is just that most of the use cases that I've seen are that you are not doing online learning. Most of the use cases I've seen are the model isn't actually changing in production. And you may be retraining the model very frequently based on new data, but you should still have an immutable artifact that is a Docker container with a model and a model server running in production, and you should still version those and have full provenance from that model back to where it came from, the data it was trained on, and so on. And in that sense, I think that it should be converging on exactly the same solution that DevOps has achieved, except it's more complicated because there's more moving parts like data versioning and parameters and metrics that need to be recorded along the way. That's just, yeah, that's my 2 pence.
Nice. Thank you, Luke.
Awesome.
Anybody else got anything they want to chime in and ask any questions? So my final question is qualities that you feel are important for machine learning engineers. You kind of touched on this, but I just wanted to reiterate that.
Yeah, I mean, I think I can speak from my own experience. Like I work at a startup, so I mean, you don't really know 100% what you'll be working on the next day, right? So in my mind, like I think number one is like the ability to pick up new stuff like really quickly. And I think that is a skill. So I think that's a skill that comes from constant, like a passion for self-improvement and a passion for trying new stuff out, like that your job might even not be giving to you, or your current environment might not be giving to you. That might include like contributing to open source. That might be, you know, setting up a webcam with like a deep learning model deployed on AWS that identifies like the foxes that come into your kind of garden and eat your like plants. They don't eat plants, but anyway, yeah, you see what I mean? So like it's this constant like strive for like learning new stuff. I think that's where that comes from. So I think that's, and like for machine learning, I think we're blessed with this amazing community nowadays. And I think having that passion, that like involvement in the community, even a voice in that community. So, you know, an attempt to put your thoughts out there, create a blog. One would say everyone does that, but really it just shows like, you know, you really want this, you really, you know, you're really serious about, if you're not already in machine learning or getting into machine learning, like it's so important. So I think, yeah, so generalist, I would say generalist, like computing, like cloud, some databases, obviously like a passion for machine learning, but not to the extent that you're going to be, implementing necessarily like the latest paper. It's all about, I think, at least in a startup environment, it's a lot about the generalist stuff. But that's just where I come from.
Awesome. Alex, this has been so informative. I am so appreciative that you got on here and you talked with us. If anyone wants to reach out to you, what's the best way to find you?
Yeah, I'm really open, like Twitter, LinkedIn, I guess. My details were there. Yeah, feel free to hit me up. And I guess I have to say here that we're always hiring for like amazing like backend engineers, and we're always interested in hearing about like machine learning engineers and product managers. But yeah, actually we're hiring across the board, so feel free to reach out about any of those roles and check out TrueLayer.
There it is, folks. Alex, I appreciate it. Everyone that came on and shared this time with us, big thank you. I'll be sending you a follow-up email with some links of interest, and have a great rest of the week. Take care, everybody.
Thank you. Bye, everybody.
Thanks, Alex. Bye.
See you guys.